if a proton and an alpha particle moves in a magnetic field with a constant momentum, what about the radiation ratio? Okay, if an proton and alpha particle moves in a magnetic field, what about that? Momentum is constant, that is momentum is to be constant. And what about the radius ratio? Radius of the proton and radius of the alpha particle we need to find out. This radius ratio we need to find it. Okay, so we know a formula. If a charged particle enters in a magnetic field perpendicularly, it will move in a circular path. The radius formula is mv divided by qb. What is mv? mv is the momentum, so I can change it as r is equal to p divided by qb. This is the formula. Okay, so in this you see that this what they told here, the momentum is to be constant and field is to be already constant, so r is directly inversely proportional to charge. Okay, what is the charge of the alpha proton? Charge of the proton is to be, what you will get, that is plus e. What about the charge of the alpha particle? Alpha particle means He24, that means it consists of two protons, that is charge of the alpha particle is plus 2e. So you see here, what you will get? Rp divided by R alpha, what you will get? So that is, you will get 1 by E divided by 1 by 2E you will get. E will be cancelled and this 2 will goes to there, so 2 you will get. That means Rp is to R alpha is equal to what you will get? 2 is to 1. This is the ratio. Okay, this is the this type, and the type 7. Okay, if an alpha particle and a proton, what about alpha particle and a proton moves constant magnetic field, constant B, okay, with the constant kinetic energy. That means here moves in a uniform magnetic field perpendicularly with a constant kinetic energy. Kinetic energy is to be constant. What about the radius ratio? We need to find it. Okay, so here magnetic field is constant, kinetic energy is constant. What about the radius ratio? Clear? Okay, so what is the kinetic energy formula? Kinetic energy K is equal to half mv square. Okay, I am going to multiply and divide by m. So what I can write here? This I can write it as mv all square divided by 2mv. What is mv? That is p. So what you will get here? That is to be, sorry, I will keep like this itself. Okay, so what is this? K is equal to mv square divided by 2m. Sorry, mv all square. What is mv? I am going to find out it here. So mv is equal, what you will get? mv all square is equal to k into 2m. What about mv? mv is equal to square root of k 2km I'll get. Okay, so now I know the radius formula. What is the radius formula? If a charged particle moves perpendicular in a magnetic field, it will move in a circular path, and the radius r is equal to mv divided by qb. You have to remember this formula. Without that you cannot solve it. If you try to derive this formula, it will take more time. Okay, better try to remember this formula. Then this we already find out. That is r is equal to what? 2km divided by qb. This is the radius formula, another radius formula. Okay, here we got another radius formula. Here is another radius formula. Here, what that is given? B is constant, that is uniform magnetic field, and the kinetic energy is to be constant. So r is directly proportional to what? Square root of m by q. Okay. Then what about the mass of the proton? Mass of the proton we know that is to be 1.6 into 10 power minus 27. I am taking it as m. Okay. Then what about the charge of the proton? Charge of the proton is plus e. What about the mass of the alpha particle? Alpha particle having 4 nucleons, that is 4m. Okay, then I already taken one nucleon, mass is to be m. Next, the charge of the alpha particle is plus 2e. Okay, now I will substitute that. So what I will get, R is equal to, Rp divided by R alpha is equal to what you will get, that is root of m, that is square root of m divided by charge of the proton. What is the charge of the proton? That is E, divided by square root of mass of the alpha particle divided by charge of the alpha particle, that is 2e. Okay, here you can see that this E and E is to be cancelled and root is to be cancelled. Then what you get here, this E is to be cancelled, then this 2 will goes to the top. Okay, and 2 will goes to the top, and there is a square root of 4 will be there. Square root of 4 is equal to 2, you will get it as 1. That is Rp divided by R alpha is equal to 1. So Rp is to R alpha is equal to 1 is to 1. This is the ratio. Okay, this is about this problem, this type of problem. Then next we will see the type 8. Okay, then the type 8. In the type 8, what they are given means, if a proton, alpha particle and an electron moves in a constant magnetic field perpendicularly, identify the path. That means electron, proton and alpha particle moves perpendicular in a magnetic field with a constant velocity. Velocity is to be constant, B is to be constant, and theta is equal to 90 degrees. So it is to be perpendicular. Identify the path. Okay, they are given the path are like this. Okay. One, two, three. Okay, magnetic field is to be acting like this. Okay, so I am assuming the magnetic field is to be acting perpendicular like that. I am taking this perpendicular. Okay, so I need to find out. Okay, first of all, I am consider what about the force acting on a charged particle. Force acting on a charged particle F is equal to Q into V cross D. Okay, clear? This is the formula, and the velocity formula is the radius formula is mv divided by qb. Okay, clear? Okay. So here what is to be constant? Velocity is to be constant, b is to be constant. Then what about the radius? R is directly proportional to m divided by qb. That means m by q is to be greater, that will have higher radius. That means what is the radius of the electron? Okay, I am taken the things about this, you see, mass of the electron divided by charge of the electron, that is E. And what about this? Directly proportional to this. Okay, and the radius of the proton is directly proportional to mass of the proton divided by this is to be I am m, like that I am taking, that is to be E I am taking. Okay, what about the radius of the alpha particle? That is the radius of the alpha particle is alpha particle having how much nucleon? There are 4 nucleons are there, 1 nucleon mass is m, then I will get it as, sorry I am writing here, R alpha is equal to 4 directly proportional to 4m divided by 2e, because 2 proton is there. Okay, this 2 and 4 is cancelled, so R alpha is directly proportional to 2m divided by E. Okay, so here the mass of the electron is to be lesser than this m, so we will take it as ME is less than M because mass of the electron is smaller than the M. So which one is the smallest radius? That should be an electron. Here you see this, which one having the smallest radius? This is the having smallest radius. So that may be an electron. So how we can find it? So if it will be moves in this direction, and what about the magnetic field? That is to be into. So I will be curved like this. Okay, if it is positive charge, it will move like this, but it is an electron, so it is to be moving downwards. So this is an electron. Okay, next. So these two will be proton or a alpha particle. Which one is to be proton and which one will be alpha particle? So you can see this. The alpha particle radius is what? 2 times of the ME. That means R alpha is equal to 2 times of the radius of the proton. Okay, that means which radius is greater here? The second radius is greater here. That is to be an alpha particle. So this is alpha particle. We'll check to the direction. You see this, if it is a positive charge, magnetic field is into it, I'll place in the direction of velocity, call it. So I am getting the forces in this direction. So it will try to rotate like this. This is an alpha particle. So this will be a proton. Okay, this is this type. Okay, now we will see the type 9. Type 9. Okay, so in this problem they have given us the magnetic field of 2 Tesla acting along Z axis. This is a uniform magnetic field, and the velocity is to be moving along the YZ plane, that is 3 into 10 power 5 Tesla acting XZ plane by making an angle theta is equal to 30 degree with the magnetic field. Okay, so what is to be the thing? Charged particle is proton. Okay, what about the force? Clear? I can draw the diagram like this. So this is the thing. So here you see this. Magnetic field is to be this handling Z axis X, Y. Okay, so magnetic field is acting like this direction. That is V is equal to 2 Tesla, and the velocity is like this. V is to be and making an angle 30 degree. Okay, what is the force acting on it? And this is a proton. If it is a proton, charge is equal to E, that is equal to 1.6 into 10 power minus 19. Okay, if a charged particle is moves in a magnetic field, it will experience a force. That force F is equal to Q into V cross B, that is QVB sine theta. Here what about Q value? Q value is 1.6 into 10 power minus 19. What about the B value? B is 2 Tesla. And what about the V value? B is 3 into 10 power 5 meter per second. This is meter per second. And what about the theta value? Sine 30. Okay, sine 30 value. What about sine 30 value? This I am taking this, multiplying this 1.6 into 3, that is 4.8. You will get 10 power minus 19 plus 5, that is 10 power minus 14. 2 into sine 30 value is 1 by 2. 1 by 2, 1 by 2 cancel. I am getting 4.8 into 10 power minus 14 Newton. This is the force acting on the charged particle. This type of problem you can expect. They will give the values and they will be asked about the force formula. Okay. And the next type we will see the type 10. Okay, in the type 10. Okay, in that the magnetic field is to be 2I plus 3J. Okay, 2I plus 3J, and the velocity is equal to 4J. Okay, and the charged particle is 2 coulomb. What about the force? Okay, clear? If a charged particle of 2 coulomb moves in a magnetic field of 2I plus 3J with a velocity 4J. Okay, what is the force acting on it? Okay, if a charged particle moves in a magnetic field, it will experience a force. That force is equal to F is equal to Q into V cross B. First, I am going to find out what is B cross B. That is equal to I, J, K. What about the first vector? That is V vector. There is no I component, only the J component. Clear? What about B? Next vector. You have I component, that is 2, and the J component is 3, and K component is 0. Okay? This I can be equated what? I into, cancel the rows and columns. So 4 into 0, 3 into 0, 0 minus 0, minus J into, this rows and column cancel, 0 into 0, 2 into 0, 0 minus 0, plus K into, rows and column cancel, 0 into 3, 0, minus 2 into 4, that is 8. So what we will get? V cross B is equal to, you will get it as minus 8K. Clear? Minus 8K you will get. Okay? Now you can substitute it. You see here, F is equal to how much? Q into V cross B. Q value 2 coulomb, and V cross B is how much? Minus 8K. Okay? So how much you will get? That is 16K, minus 16K Newton. Okay? That means the magnitude of the force is to be, magnitude of the force is how much? That is 16 Newton. That is the magnitude of the force, and it is acting in the minus Z axis.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like